Now, the part 2 of atomic structure is extranuclear portion. In the extranuclear portion, there is a remaining of what is the nucleophile and electrophile. When an atom become positive charge and when an atom become a negative charge and when an atom become a positive charge means let's consider this is the nucleus having proton plus neutrons and this is surrounded by the extranuclear portion having electrons. Let's consider positivity. When an element loses its electrons, then it will become positive. The positivity due to presence of excess protons. The excess protons can be represented as a positive sign because the charge of the proton is positive and this negative sign means nucleophile. When an atom become negative charge, it means when it gaining the electron, when it gaining the electron, that excess electron can be represented as a negative sign because the charge of the electron is negative. And next thing is what are the chemical bonds are present. And next thing is what are the chemical bonds are present in our organic chemistry. What are the chemical bonds? The chemical bonds are covalent bond, number 2 is ionic bond, number 3 is dative bond, now the first chemical bond, covalent bond. Here the covalent bond is two types. One is polar, another one is non-polar. The polarity of the molecule or an group due to polarity of the molecular element due to electronegativity difference. Due to the electronegativity difference between the atoms, that extent of the extent of electronegativity or polarity can be determined by using by dipole moment. The dipole moment is represented as a nu is equals to charge into distance. E is equals to charge of an electron, and d is equals to distance between the dipoles. What is this distance means? This, let consider an example is water. This is partial negative charge, this is having partial positive charge, and di means two, poles means charges. The distance between these two charges, this can be calculated as a distance between these two charges, and E is the charge of an electron, 1.602 into 10 to the power of minus 19 coulombs. This thing, and this dipole moment can be measured by using oscillometry. Oscillometry is used to measure the dipole moment of a molecule. This dipole moment is responsible for to determine the extent of electronegativity or polarity of a molecule. And what is the unit of dipole moment is dBi. What is the unit of dipole moment is dBi, and this polar chemical bonds can be cleavage by heterolytic cleavage. Heterolytic cleavage also due to electronegativity difference. This leads to the formation of cation or anion. In the non-polar molecule, there is no electronegativity difference between the atoms. That's why these are the non-polar, and these are cleavaged by homolytic cleavage. Leads to the formation of free radicals. Leads to the formation of free radicals. Now, how the covalent bond is formed? How this covalent bond is formed? It means by hybridization. How an covalent bond is formed, that is by the due to the hybridization. We clearly discuss this hybridization in our next class. Next, what are the other two types of bonds? Second one is ionic bond. This bond is formed due to the complete transfer of an electron, due to the complete transfer of an electron from one atom to another atom. For example, consider this. Like this, there is a complete transfer of an electron from sodium to the chlorine, leads to the complete, it gains complete positive charge and it gains complete negative charge. And in between this, there is a electrostatic attraction will be there. And this ionic bond is majorly present in inorganic compounds. Next bond is, you can see, for example, the ionic bond is present when you can see the ionic bond where means after marrying a girl can be entered into the his husband house. There is a complete transfer of an electron from an atom to the another atom. Likewise, there is a transfer of a girl from his native, her parents to his husband, towards their husband house. And next, coordinate covalent bond. Coordinate covalent bonds. If an atom containing the lone pairs, then it will give to the another atom or group which is having empty orbitals. It will give its lone pairs towards this, and that's why coordinate covalent bond is formed. This is also called as dative bond. You commonly see this type of coordinate covalent bond in complexes. In complexes, you can easily see this type of coordinate covalent bond. Then various types of chemical bonds are completed. Now what are the intermolecular forces? There is three types of intermolecular forces. Number one is Number 2, number 1 is non-polar and non-polar. Number 2 is non-polar and dipole. Number 3 is dipole. Dipole also known as Keystone forces, and this is known as Debye forces. This is known as a London forces. Here N and N it means indicating non-polar and non-polar. D means one dipole will be there, and due to the dipole another non-polar molecule will be influenced. D means one dipole will be there and another one is non-polar molecule will be there. Keystone means double E. Double E means those having same like E and E, like dipole. And what are the energies to be needed? You need to refer the book and what are the energies is needed. Try to write. This bit is asked in 2018 GPAT. What is the energy of non-polar and non-polar molecule? You refer and write it. This is homework. And let's see how these various forces are involved. This combination of three forces is called as van der Waal forces. Van der Waal forces means the combination of these three types of intermolecular forces. For example, you can see, let's take an example. Then this is the what type of forces between this non-polar part. This is polar part. Likewise non-polar and polar part. Between the non-polar and non-polar is called as what type of forces means London forces. And between this polar and non-polar, this type of force is called as polar and non-polar, Debye. And this type of forces between polar and polar, this type of forces are called as chiasm. Chiasm type of forces. So in between these two molecules, intermolecules means in between these molecules there is a presence of three types of interactions, and those interactions are called as van der Waals forces. Van der Waals forces means presence of London, chiasm and divide type of forces. So you can see van der Waals forces in between these two molecules, and how they are oriented and how they are arranged means you can easily see by using various interaction between those molecules. Now intermolecular forces are completed. Now I have to enter into the what is the application of electron concept. There is these electrons involved in sigma pi. The electrons are three types: sigma bonding electrons, pi bonding electrons, and lone pair of electrons. Because you can see this type of electrons in a molecule. Now if you take a molecule, then what are the electrons are present and what type of transitions they are undergoes, means we have to apply the organic chemistry in analysis. Now the sigma bonding, pi bonding and lone pair of electrons. Now, how is the energy of sigma, pi and lone pairs of electrons? Now you can take this compound and there is a 50% overlapping in sigma bonding. If you take pi bond, there is a 25% overlapping. When there is a 50% overlapping means maximum overlapping of the atomic orbitals that having the higher, that having the strong interaction means strong but bond between these two. And in the pi bonding there is a just 25% overlapping. 25% overlapping, it indicates just these are just simply like this. And sigma bonding means sigma bonding means 50% overlapping. And then what we need to conclude from this one is, when the various energies of an group with respect to the electrons, these lone pairs are just like sitting of two persons in a bench. When you apply very less energy, these are first undergoes excitation, because these are non-bonding lone pair of electrons, also known as non-bonding electrons. If they are not involved in bonding, they are free up. When there is interaction of light with these electrons, this lone pairs undergoes excitation first. This undergoes first excitation. After that, this is the nucleus of the carbon. This is the nucleus of the carbon. There is a distance of this electron, this nucleus. The interaction of protons of the carbon with the electrons of the other atom, that is Coulombic attractions are there, and these are far away. These are a long distance from this atom, that's why they are loosely held. And the overlapping also very less, 25% overlapping will be there. And if you consider the sigma bonding, there is a 50% overlapping. 50% overlapping means there is maximum overlapping of the atomic orbitals, that's why these are very less distance from the nucleus of this atom to this electron, and from the nucleus of this atom to these electrons. That's why this atom, the protons of this atom tightly hold the electrons of this atom, and likewise, and the distance is increased from this protons to the electrons, that's why there is a loosely held, somewhat less loosely held of these electrons, pi electrons. And the sigma electrons are strongly held with the protons present in that molecule, that's why the sigma bonding is why the sigma bond is strong. It means there is a maximum overlapping of the atomic orbitals. After that, the proton of this carbon tightly hold the electron of this atom, and these pi electrons are somewhat loosely held with the protons of this carbon atom, that's why the pi bond is weak bond. Why the pi bond is weak bond means there is a loosely held of this electron with the proton of this element, and the sigma bond is strong due to the tightly holding of this electron with the protons of this element. If you understood the three concepts clearly, then you clearly understood the concept of UV visible spectroscopy. and this is the lone pair, means not at all involved in bonding. That's why these are first excited, means less energy is required to excite the lone pair of electrons, and somewhat medium energy is required for medium energy. Less energy is needed to excite the lone pair of electron, then medium energy is required to excite the pi bond electrons, and there is a more energy is required to excite the sigma bonding of electrons. And this only the principles present in UV visible spectroscopy. You once again clearly understood this concept. According to quantum mechanics, there is a maximum overlapping of the sigma bonding orbitals, and there is a less overlapping of the pi bonding orbitals. Due to this less overlapping, there is a interaction of the proton of this element with this electron is less. That's why the pi bond is weak, and in sigma bond the proton of this carbon is having strong Coulombic interactions with the electrons of this elements. That's why the sigma bond is strong, and this one is weak bond, and this one is requires very less energy. And the same concept, the same principle you need for the UV visible spectroscopy. Application of extranuclear portion, means the electrons in UV spectroscopy. There is various transitions. Those are first lone pair of electrons undergoes transition, thereby pi electrons then finally sigma to sigma transitions. Now let's take the lone pairs. The lone pair of electrons require less energy due to these are just sitting like a two persons on the chair. That's why they are first excited with less energy. Let's consider this. And after that, the pi bonding electrons somewhat weakly held to the protons of that atom. That's why these are secondly excited, and the sigma bonding electrons are strong strong having strong having strong interactions. Due to that, this requires high energy. Higher energy, medium energy, and this require lone pairs require less energy. Then what is the transition order means? First, lone pair with pi star having less energy, then lone pair having less energy, then pi, and this having less energy, then lone pair with let's see, this portion require very less energy, and this require this thing. Next, pi and pi bonding. Sigma is always last. Sigma transition is always last due to the strong interaction in between the internuclear axis of the atoms. The energy order, like first pi bonding, lone pair with pi and pi star, then sigma bonding electrons, lone pair with sigma star, sigma with sigma star. Like this transition is purely depends upon the atomic orbitals arrangement in different groups, and that is the mainly principle involved in our, that is the mainly application of organic chemistry in pharmaceutical analysis.